So EFT, finish time, is defined as start time plus duration, or the start time is defined as finish time minus duration. Let we have a single node figure like this, 10, 20, 30. This requires a time of, this is activity A and this one is activity B. It consumes time equal to 2 and it consumes time equals to 5. So earliest start time for A is 0 plus 2. So earliest finish time for A is 0 plus 2 equals to 2. So this 2 is earliest start time for B. So this one is for A and this one is for B. So earliest start time, this one is for A and this one is for B. So earliest start time we can start at 2 because B must follow A. So what is the earliest finish time? Earliest finish time for B. So 2 plus 5, that is 7. So definition still hold. And if you can go by reverse also, earliest finish time minus duration, that equal to 5, is it 2? Earliest finish time for activity A is 2. So earliest start time will be equals to 0. Now the problem will not occur if we are preceded by single arrow. The problem will occur if we have multiple arrow. First thing is that, is the activity A and B must finish before we start the C. So earliest start time for A is 0, earliest start time for B also 0. What is the earliest finish time for A? Is 2. What is the earliest finish time for B? 3. But what we are claiming is that we cannot start C before we finish A and B. It means that this whole will be completed after 3. That is why the rule becomes the maximum of previous two roots, that is EFT of A and EFT of B. So this is how the maximum rule comes in picture. Because if you select, automatically the precedence is completed. So your answer for this one is 3. So is this one EST for C equal to 3, and therefore earliest finish time for C is this 3 plus this is 7. Latest start time and latest finish time. Is this time is the latest finish time, therefore B is equal to 7. So is it the latest start time for B? That equals to 7 minus 5 is equal to 2. So we don't have any problem in writing when it is followed by single arrow. And is this is the latest finish time for A? That is 2. So latest start time for A is equals to 2 minus 2 is 0. So this answer and this answer must match. Now come to this side. So this one is latest finish time of C is equal to 7. This one is latest start time for C is equal to 7 minus 4 equal to 3. Is same as the latest finish time of A is also equals to latest finish time of B is same as 3. So from latest finish time you subtract A, that is 2. So can we delay this activity by 1 day? If the latest start time for A is 3 minus 2, that is 1, and if the latest start time for B must equal to 0. So what is the idea for this one? You can delay this activity by 1 day. You start this activity on Monday. Monday Tuesday, Wednesday, this will finish up. If you don't have labor on Monday, you can delay it by one day. You collect your labor on Tuesday and start it. Is by Wednesday this is finished. So if you do this calculation, you can adjust your resources. That is called as slack. All information EST, EFT, LST is given in the node by dividing the node into 4 parts. Out of this space is reserved for numbers, node number. So this will be filled up as 10 or 20 or 30. This one is reserved for earlier start time. This one is reserved for earlier start time. And this one is reserved for latest finish time. Earlier start time and the latest finish time. Because if you know EST, can we calculate EFT? And if you know LFT, can you calculate LST? So we have EST and we have LFT. If there is a difference here, it is called as slack. It is called as float. So we will discuss this later on. So whatever the difference is there, this is called as EST and this is called as LFT. So this is node number 1. You have to repeat this for another one. So this space is always reserved for EST. This one is always reserved for LFT. This one is for node number and this one is for slack. We have a network like this and we want to produce the EST and LFT for this. So this activity start at 0. So write 0. If you go by this one, this is 2. Now it has 2 arrow. So you can go by this way or you can go by this way. Now if you go by this way, this one is 2, this one is 0. So this one is 2. If you come by this way, it is 1 plus 0, that is 1. Since you are forwarding, you have to select max. So max equals to 2. Then we go for this calculation. Before this, we can go for this calculation. For this 40, if we come by this one, it has 1 arrow. So this one is 2, 2 plus 3, 5. 1 arrow is this preceding. This one is 2 number. 2 plus 2, 4. So you have to select max. Max equals to 5. This is 5. This one is 0. So one value is 5 plus 0, 5. But if you come from this path, it is 2 plus 0. So this equals to 2. So what is max value? 5. So max is 5. This one has again 2 previous arrow. If you come by this one, is 5 plus 1, 6. And if you come by this one, 5 plus 3, 8. So while forward, you have to select max. So this number is 8. Now there is only one previous arrow. So 8 plus 1 is 9. So your project will finish by 9. Is this 9 is coming in? So you draw the double arrow. Now, is this 8 is coming via this path or is coming via this path? So mark it dark. Now, is this 5 is coming via this path or is coming via this path? So mark double arrow. Is this 5 is coming via this path or is coming via this path? This path. And is this, now this one, this 2, is it coming via this path? Can you identify that how you are getting 9? So 9 and this one is 8. How are you getting 8? 8 minus 3 is 5. 8 minus 1 is 7. It means that this path. How you are getting 5? 5 is coming from this path or 5 is coming from this path. So this is 2 plus 0 is 2. This is 5 plus 0 is 5. Means this path. Then how you are getting this 5? Is this 5 you are getting as 2 plus 2 or is it 2 plus 3? 2 plus 3. Make it dark. And are you getting this 2 via this path? So mark this line first. It is called as critical path. This one is 9 minus 1. Is it 8? Okay, 8. This has only one previous arrow. Is 8 minus 3. That equals to what? 5. So 5 is final. For this one, do you have two return arrow? One is via this path and one is via this path. You can come to this via 60 or you can come to 40 via 50. So if you come to this one, this is 5. 5 minus 0. So this one is 5. And if you come via this one, 8 minus 1, is it 7? So while return, you select minimum. So what is return? Is 5. Is it fine? Now this is 5 and this one, it has 2 preceding arrow, so skip this. Now how many of this one? 2 preceding arrow, one coming from this side and one coming from this side. What is this number? 5. 5 minus 2, 3, and 5 minus 0, 5. So what is medium number? So medium number is 3. But it is double path, so this will be same as 2. Check it, 2 is correct or not. What is this one? इसका medium number कितना है? 3. And we have one reverse path is this. So what is one value? 3 minus 0 is 3. And one return path is this. 5 minus 3. Is it 2? So what is minimum? 2. And for this one we have two return path. One is coming by this path. Is it 2 minus 2? 0. And this one is 3 minus 1. Is it 2? So what is medium number? Medium number is 2 minus 2, 0. 3 minus 1, 2. So what is medium number is 0. So while you return, you take minimum. While you go forward, you take max. Now, wherever your double arrow is this number repeat. So don't do any calculation for those nodes which are connected by double arrow. Only do the calculation for this one. Is it double arrow there or there is no double arrow? No double arrow. So only one calculation is required. The rest you can do blindly. 9, 9, 8, 8, 5, 5, 2, 2, 0, 0. Only one required. Now you come via this path. 5 minus 2 is what? 3. And 5 minus 0 is 5. So minimum is what? 3. That finish. So what is the slack here? Slack here is 0. 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 Slack here is 1 day. And slack here is 0. It means that if you delay this activity by 1 day, your work will not suffer. Just imagine that I will make 1 day delay. So is it finished by 2 days? It is finished by 2nd day. So this will also 2 and this will also 2. So with reference to this figure, we'll have certain definition. First term is called as path. So this is general definition of path. This one is called as starting node. We start at 0 day, and this one is finishing node. So this one is called as end node. Sometimes it is called as source node, and this one is called as sink node. Source means starting point, sink means end point. So from this point, we can have number of paths. Is one path is from 10 to 20, 20 to 40, 40 to 60, 60 to 70. Another path is 10, 20, 30, 40, 60, 70. Another path is 10, 20, 30, 50, 60, 70. Another path is 10, 30, 40, 60, 70. Another path is 10, 30, 40, 50, 60, 70. So there are number of paths. And yesterday we have done some calculation of all paths. Out of that all path, one path will consume maximum time. That is called as critical path. So right. So out of all these paths that start from 10, 20, 40, 60, 70, 10, 30, 40, 60, 70, 10, 30, 50, 60, 70, one of the path will consume maximum time. That we have done yesterday is that this path will consume maximum time. So this path is called as critical path. We start from 10, 10 to 20, 20 to 40, 40 to 50, and 60 to 70. And what is the duration of this one? So duration of the complete project is equals to 9 days. Out of number of paths, only one path is critical path, or maybe more than one critical path. If you have some different route and we get the same answer equal to 9, then we may have different critical path also. So there is no constraint on number of critical paths. All the activity that make up the critical path is called as critical activity. So this one is critical activity. Is 10 to 20 is critical activity. 20 to 40 is critical activity. 40 to 50 is critical activity. 50 to 60 is critical activity. And 60 to 70 is critical activity. The standard deviation for a critical path is given by sum of the under root of the variance of all activities along the critical path. So this is under root of sum of variance is defined as variance is defined represented by sigma square is given by Tp minus T0 divided by 6 whole square. What is Tp? Pessimistic time. TO optimistic time, square of it divided by 6. So if you want to find out the standard deviation for critical path, we must know what is the standard deviation for this critical path. Let me give the example right now. I have standard deviation for this one, that is the variance along this one is, let's say 1, this one is 2, just I am giving the value. This one is 1, this one is 2, this one is critical variance is 3. So I am just quoting this in root bracket like this. All these values are variance. We can calculate all these values in case of PERT only, not in case of CPM, because CPM we have only one value. So let's say this equals to 4. Let's say, so what is this sum for this particular case? So this sum equals to under root of, this is critical activity, that is 1. Then this is critical activity, that is 2. Then this one is critical activity is 0. So this one is 2. And this one is 2. Then this one is what? 3. So 3 plus 2, 5. 5 plus 3 is 8. So this value equals to root 8. Okay. So you can very well calculate the variance for any critical activity. The normal deviation is defined as desired completion of time, desired expected completion divided by the standard deviation. So what is the standard deviation? Is this value is equals to what? Root 8 for present example. What is desired completion? How many days we want to finish this project? So right now, what is the expected time? Is it 9 days? Desired, whether you want to finish this project in 10 days, 11 days, 9 days or 8 days. Then we can check out what is the probability that this project will finish up. Suppose I say that my desired period is 9 and my completion period is also 9. My completion period is also equals to 9. So this is minus 9 divided by SD. SD is root 8. But what is the numerator? Numerator is 0. So this one is normal deviation, which is normally represented by Z. Then probability of completing this we can find out from PZ. So PZ equals to what? P0. So in case of normal distribution, the normal deviation is represented by Z. Desired period is represented by X. Expected completed period is represented by mu. And standard deviation will be represented as sigma. X is called as desired completion, mu is called as mean or expected completion period, and sigma is called as SD. On x-axis, that is on this axis, we have a probability. So let me have here one other axis. Axis represents probability and this axis represents Z. The middle line is represented mean, is called as mu. Then there is a division of this line. So this range is called as 1 sigma range. So this is mu plus sigma. This value is mu minus 1 sigma. So this is a band for 1 sigma. Similarly, we have a band of 2 sigma. So this one is 2 sigma band. So this one is mu plus 2 sigma and this one is mu minus 2 sigma. And finally, we have a graph of 3 sigma. So this one is mu plus 3 sigma. Exactly at middle point, your probability will be 0. If you are on the right hand side, that your value is more than mean value, or Z value is what? Positive value. This is 0. So Z value is what? Positive. So if Z is greater than 0, then your probability is also greater than what? This one is not 0. This one is what? 50%. Mu means here is the value of z equal to 0, sigma equal to 0. So this value is z greater than 0. So probability for this case will be greater than 50%. And if you are on the left hand side, your probability will be, your z will be negative for this side. This is mean value, z is positive or 0. This is z is 0. On this side z is negative. So probability of z is less than 50%. This is how your distribution, normal distribution will work. Area under whole diagram is equals to 1. The probability is basically the area on the left hand side of that particular value. To what? 0. So this value corresponds to z equal to 0. So if I say z equal to 0, I have to consider on left hand side area. Is the left hand side area is the 50% of the total area. Why this is so? Because we have symmetry above this axis. That is why your probability is coming out to be 50%. If this z value is more than 0, let's say here, suppose z value is more than 0, let's say z equals to 1.2, then is the graph on the left hand side having this area? So is this area is more than 50%? So this is the reason why your probability is coming more than 50%. What is the maximum probability will be equals to 1. And if you consider this value, let's say this value equals to z equals to minus 1.2, then is the area behind this one is very small area. Is this area is less than the 50% of area. That is why if you work on the left hand side, your probability always less than 50%. Exactly on mean, your probability is 50%. And if you are on the right hand side, your probability will be more than 50%. Justified? This is how the graph works. 0.5. Okay. Now if I say sigma equals to 1, so what is the probability of 1? 0.84. What is the probability of minus 1? Is it 0.16? That is very close to 0.16. What is the probability of 2? 0.97. What is the probability of minus 2? 0.03. So this one is 9 at them. What is the probability of 3? 0.989. So this one is 0.999 something. Is the probability of minus 3 is 0.0000 something is 1. Okay, now try to understand what I want to say you. If your point in between this sigma, is it correct? This is 1 sigma. So if you are in this row, in this zone, is your probability is more than 50%. And what is the range for this one? Is 84%. Is it correct? It means that you are going to cover how much area of the total graph? 84%. So 1 is here, so you are going to cover 84%. 2 is here, so how much you are going to cover? For 2, 98%. And for 3, you will going to cover how much? Almost complete graph. And see this sum. Is this sum is equals to 1? What is the meaning of probability of 1? Probability of 1 is this area. Is it correct? And what is the probability of minus 1? Is it this area? Is this area is probability equals to what? Minus 1. And what is the probability of 1? Is the probability of 1 is this area. Now, since the graph is symmetrical, is this black line is the same area as this one? So the total area will be equals to 1. Now check this also. Is it also 1? And this is also equals to 1. So your band is there. This is called as 1 sigma band. This one is called as 2 sigma band. And this one is called as 3 sigma band. 1 sigma, 2 sigma, 3 sigma. 1 sigma is how much? 84. 2 sigma is how much? 98. And 3 sigma is what? 0.99. There are 3 types of float. The first one is called as total float. Second one is called as free float. And third one is called as independent float. Type of float that is called as interference float, but we'll introduce later on. So we have 3 types of float. This activity we'll call this activity is I. and we call this activity equals to j. This one is duration for ij activity. Yesterday we label this one is 10 and this one is 20. So I is previous and j is next, and tij is called as duration. Is this time is called as earlier start time. This one is also called as earlier start time for j activity, and this one is earlier start time for ith activity. This one is called as latest finish time for jth activity, and this one is called as latest finish time for ith activity. This total float is given by latest finish time of jth activity minus earlier start time of ith activity minus duration, that is Tij. That is the technical definition of total float. Outer is total float. This one is called as independent float. So what is the definition of independent float? Is it the earlier start time of j activity minus is it latest finish time of ith activity minus duration Tij. That is the definition of independent float. So the free float is the difference between EST, earlier start time of activity I or J minus earlier start time of activity I minus duration Tij. Outer is total, inner is independent, first is free float. Path all float is equals to 0.